Hello, everyone. My name is Keith Jackson, and welcome to Jack's Math Notebook. Right now, you're looking at the third and final video as it relates to the understanding of the greatest common factor alongside the least common multiple. And we put them together so we can gain a deeper understanding how one works versus how the other one works. Now, let's take a look at the greatest common factor. And what we're going to do, we're going to use prime factorization to arrive at our greatest common factor. And we're going to do the same thing to arrive at our least common multiple. And so let's go back to the greatest common factor of 54 and 63 using that prime factorization. And what we're going to do, we're going to start off by finding the first prime number that can be used when we multiply, let's say, two numbers. And so then the question is, what two numbers, when we multiply them together, give us 54, provided that one of those numbers is a prime number? The good news is that 54 is an even number, so we can always get out a 2. 2, believe it or not, is a prime number, and it happens to be the only prime number that is even. So we can use 2 times 27. All right, so 2 times 27 will give us 54. And now we can use 27. We can say the same thing about 27, but 27 is an odd number. But the fortunate thing is that we can fish out a 3 because 27 can be divisible by 3. And 3 is a prime number. And so then the question is, what two numbers, when we multiply them together, will give us 27, provided that one of those numbers is a prime number? And that answer is 3. And we know that 3 times 9 will give us 27. We're going to do the same thing with 9. We know that 9 times 1 give us 9, but also 3 times 3 give us 9 as well. And we know that 3 is a prime number. And let us circle all our prime numbers so we know that we're finished using the prime factorization method for 54. And in fact, 2 times 3 times 3 times 3 will give us 54. Now let's do the same thing for 63. And we can ask that question. What two numbers, when we multiply them together, will give us 63, provided that one of those numbers is a prime number? 63 is an odd number, but it also happens to be divisible by 3. And so we're going to use 3. And we know that 3 times 21 will give us 63. All right, 3 times 21 will give us 63. And now we could do the same thing with 21. And we can ask ourselves that question because it is an odd number. So, what two numbers, when we multiply them together, would give us 21, provided at least one of those numbers is a prime number? And there you have it, 3 times 7. And the good news is that 7 is prime as well. So, we can circle all our prime numbers right here. And so 3 times 3 times 7 will give us 63. And now here's how we find our greatest common factor of 54 and 63. We're going to stack up only the shared prime factors. And the only prime factor that they share is 3, and they share two threes because, see, at max, there are only two threes here. Although we have three threes, we can only use two of those threes because they at least have two threes in common. And so we're going to write for 54 two of those threes that we see right here. And for 63, we're going to write the two threes that they have right here, the two threes that 63 has right here. And we're going to stack them one on top of one another, creating these two columns. And then we're going to bring down that 3 here, and then we're going to bring down this 3 here, knowing that 3 times 3 will give us 9, and 9 is our greatest common factor for 54 and 63. And if we were to line up 54 over 63 as a fraction, we will know that if we divide both numbers by 9, it will simplify to its simplest form of 6/7. Because 54 divided by 9 is 6, and 63 divided by 9 is 7. Excuse me, I had to clear my throat for just a second there. But now I'm ready to keep on going with the least common multiple of 54 and 63 using those same prime factors. And what we're going to do in this case, we're going to stack up the prime factors to make columns. We're going to utilize all the prime factors for 54. We're going to utilize all the prime factors for 63. And we're going to line them up, making sure that the ones that they share, we line them up one on top of the other. And so we have right here for 54, 2 times 3 times 3 times 3. And for 63, we have 3 times 3 times 7. And notice how I paired up the prime factors that they have in common, and the ones that they don't have in common, well, we just let them stand alone here and here. And so we have that 2 right here and that 7, and this 3 right here standing alone. And so we're just going to use them anyway because we're going to bring down the 2, we're going to bring down the 3s, we're going to bring down the 3, we're going to bring down the 3 right here, and we're going to bring down the 7. So again, let me repeat that. We're going to bring down this 2. Since we have a pair right here, we're going to bring down the 3. Since we have a pair right here, we're going to bring down this 3. Since we have a 3 here, we're going to bring it down. Along with that 7, we're going to bring it down. And here's what's going to happen. When we multiply 2 times 3 times 3 times 3 times 7, our answer is going to be 378. So the least common multiple, or the first common multiple that 54 and 63 have in common, is 378. That is the least common multiple. Notice how big this difference is between the 378 and the 9. The greatest common factor, okay, is the highest number that 54 and 63 can be divided into together. And at the same time, or I should say differently, when you count by 54, when you count by 63, the first number that they're going to have in common is 378. Okay, so that's the difference. And this is how the greatest common factor works, and how this is how the greatest common factor works, and this is how the least common multiple works. All right, so it's good to kind of, just kind of gain a deeper understanding of how to apply, let's say, one of these concepts versus the other concept. Okay, you have been given a lot of information, and I wouldn't blame you if you need to pause the video to take a look at the greatest common factor, then look at the least common multiple. Or you can replay this video as many times you need to gain a deeper understanding of these two concepts. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.